Alright guys, let's continue from where we picked up last time. Last time we saw Visionaire and Caesar cipher and how they work. Let's now see how to break them. Okay, now we already see how to break Caesar cipher. Again, if this was F and K and D and then what is that, I, L, and might be wrong, I don't care, U. We already seen how to break them, because since it's a thing that repeats on every letter, we can just try every key and eventually we're gonna find a way to go back here. So we see that breaking this is pretty trivial, so let's just consider, let's forget about the Caesar cipher and let's just consider the Visionaire cipher. How do we break this? Now, breaking an algorithm means that from a ciphertext, F, B, H, K, from a ciphertext, and knowing what kind of cipher was used, I am able to go back to the plain text. That means breaking an encryption from here, going from here to here directly without knowing the key. That's because if I knew the key, then I would be doing decryption. So I don't know the key and I'm breaking. How to break this? So a few things. So this is not as simple as the Caesar cipher, so you can really, I mean, you can still brute force if you have and try all different keys, AAA, ABP, CCC, DDD, DA, etc. until you get to this combination of letters. Or you can do something called frequency analysis, right? So let me see one thing. No. Perfect. Exactly. So here you can do something called frequency analysis. So there's a thing, so we're encrypting English language, right? An English word. There's a thing about English letters and English language, which is that if you take any given paragraph and the more words you have, the better, you're gonna see that the most used letter of the alphabet is gonna be the letter E. And then the second most used letter of the alphabet is gonna be letter, I'm not sure, probably another vowel, but that's the logic. Why? How this allows us to break the encryption? Obviously, this is too much short of an input to use it here, but let's pretend we're actually encrypting a secret paragraph of text. So a lot of text right here, and a lot of text right here, all encrypted. To break this, we're gonna count the most common letter here, which let's say it's letter K. No, K can be because it's R. What does E encrypt to? Whatever. Let's say it's letter N. If there's a lot of letter N's in our text, then we can assume the plain text, that's the letter E. Now, one thing also about the frequency analysis is that you can, since the key is three digits long, then you can start seeing patterns maybe repeating letters 3 at a time. So that allows you also to get a hint that the encryption key is either 3 or a multiple of 3 digits long. So these are unsecure algorithms. They were very secure at their time, and they're breakable. And the fact that we can figure out these little hints from our ciphertext to then assume something as a key, it just makes it way more brute forceable. Why? Because if I see from the pattern of lettering, from the frequency analysis, that everything repeats after, there's a pattern that repeats every 3 or 9 digits, then I know that my key is a multiple of 9, and then my brute forcing algorithm is just gonna try all possible 3-letter combination. A, B, 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 C, 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 A, B, B, A, C, C, A, D, D, whatever order you try. And it's gonna be much easier than not knowing how long the key is. So by, let's see, frequency analysis, yeah, we did that. So from this, knowing how this first algorithm works, we can start looking at how these ciphers work, right? And we can see that ciphers are made of a, right here, ciphers are made of a permutation plus a mode of operation. Now we're zooming into, we're kind of a little bit opening up the box a little bit here, and we see what are the properties of a cipher, of an encryption algorithm, right? So permutation is literally the process of how you're going to replace the information, how you're going to substitute the data, right? Because here we're substituting letter now. This encryption worked letter by letter. Keep in mind, guys, that modern encryption algorithms, the one they use in computer software, in information technology now, they don't work on letters like this. They don't swap letters, but they do. So let's see, in a computer, the word chair is basically stored as a number. Now, I don't know exactly what's the ASCII code, what's the code for C, but let's say it's 33. And then this 33 is stored as a 0, 1, 1, 1, 1, 0, 0, 1, 0, 1, etc., etc. Well, maybe it's too big for 33, but I'm throwing random numbers, but what I'm trying to explain here is that now we're working with letters because these are old algorithms, but keep in mind, just keeping in mind that in modern encryption, computers will encrypt bits, okay? So the permutation, which is the algorithm that dictates how these information, how the plain text units get converted into ciphertext pieces, computers will work with in here. So just as the Caesar cipher shifts a C into blah 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 based on the ABCD alphabet, this another encryption algorithm might be using a permutation to flip the bits to do some operations and to change them into another bit, which in turn codifies to another, let's say this is 45, which then gives me another letter, or even like a number or symbol, let's say it gives me back a K. So this is the permutation, where each of a cipher, the way to which each bit of information gets substituted. Now, what's peculiar about the permutation, what's important about the permutation is that it needs to substitute something in a unique way. If not, the cipher is not valid, it will not work. Why is this important? Because if my permutation, so what is the permutation in Vigenère cipher? The permutation is shifting a letter according to the alphabet, right? So if this permutation made me end up, so let's say that C, using obviously C, always becomes, you know, if I flip with the key, it always becomes F, right? If something else would give me the same F, now we have a problem, because then we won't be able to differentiate. Actually, let me explain this better. So permutation is dependent on the key. This is the fundamental thing. the key determines the permutation, okay? So in this case, this key determines how these letters are flipped. And according to this permutation, we're always gonna have this result if we encrypt this with this key. If the permutation was such in a way that today we encrypt it and it becomes like this, but tomorrow we encrypt it again and it's something else, then obviously this is not a valid encryption algorithm, because an encryption algorithm has, with one determined key, has only one output. Now this seems obvious, obviously you might be thinking, but that is one property of a cipher permutation. Another thing is that just like this key gives the same, different keys, so if we use hola as a key instead of DUH, then we're gonna have a different output. Because if two keys give the same output, again we have a huge problem, because we're just gonna how can I say, we're gonna reduce the possibilities of chaos, right? We're gonna make more easier to this algorithm to be broken, because more keys generate this output. Therefore it's easier for me to stumble upon a key that will give me this output and break the encryption. Now the third thing about permutation is that they should look as random as possible. Obviously this to us looks random, but again we saw in frequency analysis that there might be patterns in larger text that repeat. And so this permutation is okay, it satisfies the fundamental properties, but it's not crazy random, it's not crazy secure. Now, we've talked about permutation. Now, what is the mode of operation? The mode of operation is basically the algorithm that uses the permutation to process an arbitrary input, right? Of any size. Now, what's the mode of operation of Cipher cipher? The mode of operation of Cipher cipher is to apply the permutation after each and every letter, okay? So, delete this so I don't get confused. So the mode of operation of the Cipher cipher is to go into each element of the data and apply the permutation to each. What's the mode of operation instead of the Vigenère cipher? Now the mode of operation of Vigenère cipher is again slightly more complex, and it consists into applying the permutation, which is the shift according to the key, you know, every 3 letters, because our key is 3 times. So this is what permutation and mode of operation are in the context of a cipher. So a cipher again uses a permutation to substitute letters of the plain text into letters here, but again guys, we can use bits or symbols, anything. Is how you represent the data doesn't matter, especially for computers. For us matters because we understand letters, we don't understand the bits and the Alright guys, so basically the camera ran out of battery right when I was wrapping up the video and explaining. So let me go back to the train of thought. So again, let's do a summary. We went over how to break Cipher cipher and how to break Vigenère cipher. And then we used those topics that we covered to dig in a little bit more into what a cipher, what an encryption algorithm is composed of, is made of. And we talked about the fact that ciphers are made out of a permutation plus a mode of operation, okay? And again, the permutation is the way to which each piece of data gets substituted, and we saw what were the important things about it, that it needs to be determined by the key, that it cannot, with different keys, produce the same output, and it should be as random as possible. And then we saw the mode of operation, which is basically the way in which the encryption algorithm, in which the cipher applies the permutation. So in the Caesar cipher, it's applied at every piece of data. In the Vigenère cipher, is applied every 3 pieces of data. What I mean by pieces of data is literally the elements that we're substituting. In our example that we just did are Latin letters, because it's easier for us to understand, and because those were ancient, classical, ancient older encryption algorithms. But keep in mind that for the next, in the next videos, we're going to see more complex encryption algorithms, and we're going to see that the instead of working on letters, they work on bits, because that's how computers represent letters and data. So it really doesn't matter what the data is, how it's represented, that doesn't matter. What matters is that we're applying a cipher, which basically means that the cipher applies a permutation to each element according to a mode of operation. Now, it's very important for a strong cipher that the permutation and the mode of operation both are very random, because a weak, we saw when breaking the, for example, when breaking the Vigenère cipher and doing frequency analysis, we exploited a weakness in the mode of operation, which is the fact that it repeats every X letters of the key. That's a weakness in the mode of operation. So thank you for following through. We covered the most 2 basic and all the forms of encryption. Next time we're going to, and also we covered what are the elements of a cipher, the permutation and the mode of operation. I think is very important. Next video we're gonna do the one-time pad, which is called the perfect encryption. So I'm gonna study up, and I'll be doing that in the next video. Thank you for watching. I'm having a lot of fun. This is a lot out of my comfort zone, because it's the first time making videos, and again, I never approached cryptography ever in my life. I can always study the minimum necessary, you know, to implement the programs, but I really want to step up my skills and become fluent in cryptography. No more, this is out of my comfort zone. I'm trying to do this, and so I hope you're enjoying it. Let's learn together, guys. Let's do it. See you next time, and enjoy. Bye bye.